Hello everyone, today we're going to look at graphing y equals a sine of bx and y equals a cosine of bx. So sine and cosine curves are called periodic, which means they repeat a cycle forever and ever in both directions, negative infinity to positive infinity. The length of each cycle, which again is the thing that repeats, is called the period. The frequency of the cycle or the graph is 1 over the period, which tells us how many cycles appear in either 360 degrees or 2 pi radians, depending on which unit we're working with. So we have the following definitions. The amplitude, which is the absolute value of a, which is that coefficient in front of the trig sign, that is half the distance from the minimum to the maximum. Now recall that sine and cosine are both bounded in absolute value by 1. Right? No matter what angle I'm looking at, sine and cosine is at most 1, and it's bigger than negative 1. So it's bounded between negative 1 and 1. The period is 2 pi divided by b, and that's the coefficient of x if it's in radians, or 360 degrees divided by b if it's in degrees. So remember, a full circle is 360 degrees and 2 pi. So if we're going back and forth between the different units, always remember that we're talking about a full circle, right? 2 pi radians or 360 degrees. And then the frequency, again, is the reciprocal of the period. So it's b over 2 pi or b over 360. So that b is going to tell us how many cycles appear in one full circle. So we're going to look at a couple of graphs right here. The first two are y equals sine of x. The first one is in degrees and the second one is in radians. So notice the shape of the picture is the same. The only difference is the x values. But we're always going to have 0 degrees is 0 radians, 90 degrees is pi over 2 radians, 180 degrees is pi radians, 270 is 3 pi over 2, 360 is 2 pi. Okay, so again, it's the same exact picture, just the x values are the converted values from radians to degrees. And the same thing with cosine. Down here we've got cosine in degrees and cosine in radians. So what I really want you to notice is the shape of these two graphs, the sine curve versus the cosine curve. So the sine curve, I'm going to say in quotes here, starts at 0. Remember, the graph goes off in both directions, so there's no real starting point, but we're going to figuratively say it starts at x equals 0. So for sine, when x is 0, y is 0. Again, we're kind of quote-unquote starting at the origin. And then we're going to look at those angles that are on the axes, if we're looking at like a unit circle. So that's the 90 degrees, the 180 degrees, the 270 degrees, the 360 degrees, or in radians, pi over 2, pi, 3 pi over 2, and 2 pi. So notice that those are the angles that are graphed in both sine and cosine cases. So those are the 4 points that we're going to, or 5 points really, starting with 0, that we're going to concern ourselves with. So those 5 points in either the sine or the cosine graphs are either zeros, like they are for sine at 0, 180, and 360, or they're maximums and minimums. So in the cosine curve, 0, 180, and 360 are the maximums and the minimums. For sine, we have the maximum and minimums occurring at the 90 and the 270, or the pi over 2, the 3 pi over 2, and that's where the zeros are for cosine. So in either case, our minimums, maximums, and zeros are going to occur at those 5 points. 0, and then a quarter of what our period is in this case. So notice our period is 360 degrees, or 2 pi. And hopefully that makes sense, because b in this case is 1. So we're going to take 2 pi or 360 divided by 1, and that's going to be our period. Okay, so we're going to focus on, again, those 5 points, 0, what's going to end up being a quarter of the period, half the period, 3/4 of the period, and the period. So for now, it's those 4 or 5 again, angles on the axes. The A is going to change the y values in the following way. So again, the absolute value of A is the amplitude. So A can be negative, right? But the amplitude is a distance, so that has to be positive. That's where we have the absolute value come into play. So if A is not 1, then instead of sine being bounded by 1, it's going to be bounded by the absolute value of A. And the same is going to be true with cosine. If A is negative, the graph is flipped upside down. So anything that was a maximum is now a minimum, and anything that was a minimum is now a maximum, and everything in the middle is going to get flipped as well. The B value, which I kind of talked about a little bit, changes the x values. And again, I talked about the fact that the mins, maxims, and zeros are going to occur at 0, a quarter of the period, half the period, 3/4 of the period, and the period. So I'll tend to just use p here, where p is the period of the graph. Remember, that's 2 pi divided by b, or 360 degrees divided by b. So let's do some examples. So let's graph y equals 4 sine of x in degrees. So the amplitude is the absolute value of A. A is 4, so the absolute value of A is also 4. The period is 360 degrees divided by B, but B is 1, so the period is 360 degrees. So we're going to write our 5x values. So again, we start with 0, and then we're going to take a quarter of the period. So 360 divided by 4 gives us that 90 degrees. So that's going to be my next x value. And then I'm going to take another 90, and that gives me 180. And then another 90, and that gives me 270. And then another 90, and that gives me 360. So again, that's 0, a quarter of the period, half the period, 3/4 of the period, the period. And then we're going to look at the fact that it's a sine curve. So for my y values, going back to that original sine curve function, we saw again that it kind of quote-unquote starts at the origin. So if x is 0 degrees, then y is 0. And now again, these 5 numbers, they're either the minimum, the maximum, or the 0. So the 0 is 0. The maximum is 4, and the minimum is -4. Because remember, a sine of x is bounded between negative a and a. So the minimum is, again, an absolute value. So I should really have absolute value signs there. So the minimum is -4. The 0 is 0. The maximum is +4. So for my sine curve, it starts at 0. The next value is the maximum, then 0, then the minimum, and then 0 again. So I'm going to fill those in for the table. So 0, 4, 0, -4, and 0 for the y's. So we have this table, and then we want to graph it. So notice that all of our 5 values are equidistant on the x-axis, right? Again, they're all a quarter of the period. So when I plot them, they should all be equidistant from each other. So I've got the 0, I've got 90 degrees, 180, 270, 360, and then I'm going to draw kind of a dashed line here. And I'm going to have my 4 and my -4. And then I'm going to graph it. So I got my 0, 0. I've got my 90, 4. I got my 180 degrees, 0. My 270 at -4. And my 360 at 0. So remember, this curve is going to repeat. So whatever y value I started with, I need to make sure I end at that same y value. Otherwise, I can't repeat my picture. And then when I go to graph it, we need to remember that these are sine and cosine curves. They are not straight lines. So do not connect the points with a line. Okay, they're curved. It looks like a wave. And that would be it. I only have to draw one cycle, but again, just remember that it would keep repeating in both directions forever and ever and ever. Okay, so that's our first example. Let's try another one. Y equals -1/2 cosine of x in radians. So I start by finding my amplitude and my period. So my amplitude, again, is absolute value of A. So A is -1/2. The amplitude is +1/2. Again, it's a distance. It has to be positive. My period, if it's in radians, is 2 pi divided by B. And again, here B is 1. So I'm going to start with my x values. So I always start at 0. And then I'm taking 1/4 of my period. So 2 pi divided by 4 is pi over 2. You always want to leave your answers here in terms of pi, so a fractional coefficient or an integer times pi. We don't leave decimal coefficients of pi, so this would not be 0.5 pi. Okay, it's pi over 2 or 1/2 pi. Don't put decimals. So my next number is going to be pi over 2. And then we do another pi over 2, or we do half of the period, which gives us pi. And then we add another pi over 2, or take 3/4 of the period, and that's 3 pi over 2. And the last number, the fifth number, is the period, 2 pi. So now we're going to look at cosine. So if we go back to that original drawing of cosine, my first, that's not quite true, my first number was a maximum, and then 0, and then the minimum, and then 0, and then the maximum. So those are my 5 points. But my coefficient is negative. So that means that my picture is going to get flipped upside down. So every maximum becomes a minimum, every minimum becomes a maximum. But notice the zeros stay the same. So there's still zeros in these two spots here. So this will be a 0, and this will be a 0. But now I'm starting at a negative. And that negative is going to be, again, the negative of my amplitude. So this is going to be -1/2 and +1/2. Okay, so we're going to start off at -1/2, then 0, then +1/2, then 0, then -1/2. So we get those guys. And then I could pretty much just graphed it, but I'll fill it in correctly here. So then I have 0, then I have pi over 2, then pi, 3 pi over 2, 2 pi. Down here will be -1/2. Up here will be +1/2. And then, again, since it's negative, we're starting at -1/2, 0, 1/2, 0, -1/2. And again, just make sure that it's curved here. Okay. So they kind of look like parts of a parabola, but it's not quite the same as a parabola, but it's close if you want to think of it like that. So that is an upside down cosine curve because A is negative. How about y equals 2 cosine of 4x? And we're going to do it in radians. So again, the amplitude is the absolute value of A, which is 2. The period is 2 pi divided by B. B is now 4, so this is the first time we're changing the period. So that 2 pi divided by 4 gives me a period of pi over 2. So if I start filling in my table, again, the first value is always 0. And then we're going to take our period, divide it by 4. So remember, if I have a fraction and I'm dividing it by something, I want to multiply by the reciprocal. So I'm going to take my pi over 2, and I'm going to multiply by the reciprocal of 4, which is 1 over 4. And this gives me pi over 8. Okay, so I'm going to have pi over 8, and then I'm going to keep adding pi over 8 until I get to my period. So pi over 8, and then pi over 4, 3 pi over 8, pi over 2. So always check, make sure your numbers are increasing, and they're increasing by the same amount each time. And then I go to my y values. So again, I have cosine. So again, that's going to start, if I just do a graph right here, and I didn't do it very well, it's going to start at the maximum. And that maximum is my amplitude, which is 2. Once I'm at the maximum, I only have one place to go by definition of maximum. I have to go down. And before I can hit the minimum, which I know is a negative number, I have to hit 0. So if I can just remember the fact that cosine starts at a maximum, it has to go down, which means it has to hit 0 before it can hit the minimum. So 0 is my next of those 5 points, and then I keep going down until I hit the minimum. Once I'm at the minimum, I have to go up by definition of minimum. And before I can hit the maximum, I have to hit 0 again. So 0, and then the maximum. And again, I have to make sure that I'm ending where I started in the y values. So I'll use my table and I'll plot those points. So pi over 8, pi over 4, 3 pi over 8, pi over 2. My minimum is at -2. My maximum is at 2. And then again at 0, I'm at my maximum, then 0, then my minimum, then 0, then my maximum. I have a very nice, again, in this case, positive cosine function. Let's try negative sine of x over 2. This time we'll do it in degrees. So start with the amplitude. Again, a is -1, the amplitude is +1. The period is going to be 360 divided by 1/2. So again, we're going to take that 360, it's an equal sign, multiply it by the reciprocal of 1/2, which is 2. And that gives us 720 degrees as our period. Okay, so be careful when b is a fraction. Make sure you're multiplying by the reciprocal. And again, x over 2, that's the same as 1/2 times x. So that's why b is a half. It's okay. So we'll start with our x's. Again, we start at 0, and then I'm going to take 1/4 of 720, and that's going to be 180. And then I add another 180, and that number is half of my period. Then I add another 180, and that's 3/4 of my period. Add another 180, and that's my period. So sine, and the general picture looks like this, but we're flipping it because we've got a negative. Whoops. So if everything gets flipped, let me do that in a different color. Okay. So we're still starting at 0, but then we're going down instead of going up. So we're going to have 0, then our minimum, then 0, our maximum, and then 0. And again, our minimum being -1, our maximum being 1. Right, so we get 0, -1, 0, 1, 0. And then we go to graph it. I have 180 degrees, 360, 540, 720. And I'll try to make these as straight as possible. Minimum at -1, maximum at 1. Start at 0, then a minimum, again because of that negative sine curve, then 0, maximum 0. And we have our very lovely upside down sine curve. Let's try another one. How about y equals 3 cosine of 3x over 4 in radians? Okay, so our amplitude is going to be 3. And then our period, again, we're going to have 2 pi divided by 3/4. So 2 pi times 4/3, right? So again, multiply by the reciprocal. So that gives us 8 pi over 3. So that's going to be our period. Start with 0, and then we're going to take 1/4 of our period. So 8 pi divided by 3 divided by 4 is times 1/4. Right, cancel a 4, and we've got 2 pi over 3. So 2 pi over 3 is going to be our first non-zero value. And then we're going to double that, or take half of 8 pi over 3. In either case, we should get 4 pi over 3. Our next value is 3/4 of the period. So I'm going to take 2 pi over 3, which was 1/4 of my period, multiply it by 3. Whoops. And we get 2 pi. So 2 pi is going to be our fourth value. And then our last value is always the period. So that gives us our x values. For our y's, we have cosine, and cosine starts at the maximum, which is 3, our amplitude. Once we're at the maximum, we start going down until we hit 0, and then we keep going down until we hit our minimum, -3. Once we're at our minimum, we have to go up, so we'll hit 0. And then lastly, we'll continue going up till our maximum. And then we'll graph it. So we've got 2 pi over 3, 4 pi over 3, 2 pi, and 8 pi over 3. Our minimum is at -3. Our maximum is at 3. And then we'll graph it. So we're going to start at our maximum, hit 0, go to our minimum, go up to 0, and then hit our maximum again. And we'll do 1. So y equals 1/3 sine of 2x in degrees. Our amplitude is 1/3. Our period is 360 divided by b, which is 2, so we get 180. Start at 0. I'm going to take 1/4 of our period, so 180 divided by 4. That gives us 45 degrees. The next one is either twice that or half of the period. In either case, that gives us 90 degrees. And then we get 3/4 of the period, which is 3 of our quarter, which is 45, so 3 45s. Gives us 135 degrees. And then our fifth point is our period, 180. So for our y, sine starts at 0, then goes up to our period, our amplitude rather, which is 1/3. Then at our maximum, we go down back to 0. Keep going down to the negative of our amplitude. And then once we're at the minimum, we can only go up until we hit 0. And then our last step is to graph it. So we have 45 degrees. It's terrible. 90 degrees. 135 degrees. And 180 degrees. Our minimum is -1/3. Our maximum, is +1/3. And then connect them. So again, sine, we're going to start at the origin and then go up. Then we'll hit 0, go down, and then come back up again. Okay, so practice, again, make sure you know the basics of sine and cosine so that we can manipulate them. So here we've stretched and shrunk the graph. We've done it vertically, that's changing in the A, and we've done it horizontally, that's changing in the B. Next time we're going to be moving the graph. So we're going to move it up and down, and we're going to move it left and right. Okay. So try it out and let me know if you have any questions. Thanks.